Okay, hi. So we are looking at the Math 1315 section 6.8 homework problem number 12. If you didn't watch the previous two videos, you might want to stop and watch the example for number 10 and number 11. This is the same idea. We're still graphing a piecewise function, but this time we're just going to stick to using a graphing utility. If you want to see kind of how to graph it without using a graphing utility, definitely, like I said, look at examples 10 and 11, but we're going to look at just not using a graphing utility just to give us an alternative way of doing this. So just to kind of reiterate, I have my graph, it's broken up into three different parts, three different pieces. Okay, so piecewise functions broken up into pieces. Sometimes those pieces are connected and sometimes they're not. At this point, I'd have to look at it to kind of see if they're kind of connected. So I've got these three pieces, and I call it piece one, piece two, and piece three. I'm not very creative. I'm a math teacher. So I've got purple piece, pink piece, blue piece. Okay, those three pieces. Your pieces are based on what value of X you have for your input. That determines where your output is. So, you might be asked to find, for example, like f of 2, then you've got to go and look at, well, where is 2? Is 2 less than or equal to -4? No. Is 2 between -4 and 3? It is. So my output's just going to be straight -3. And of course, it doesn't meet that third criteria because we already found it. And functions only have one output for each individual input. Okay, so one of the ways is you can look at making a table of values. I see that for the open interval from -4 to 3. I'm going to have just a constant. My function is going to be constant. For x less than -4, I have the line y equals x plus 3. This is a line with a positive slope, so it's going to lean to the right. It's going to be increasing. So that told me my graph is going to be increasing as I go from x, negative infinity up until x being less than -4. So looking at this left one where I have A, of course, I definitely know it's not going to be A. And similarly, it's not going to be B because each one of those has, for x less than -4, it has a negative slope, B negative slope. So C and D are my next options. From there, I look at where my function's constant, and it's going to be constant. Erase it so I can grab some more space. My graph is going to be constant on the open interval from -4 to 3 for my x values. And for those values, I'm going to get a consistent output of -3. So I see that here, this function for C is remaining constant from on the open interval from x equals -4 to +3, whereas D, it's constant from -4 to 3, including. So we're going to cross that off, and that tells me that the C is my correct graph. Now, that's if you have multiple choice, but like I said in this video at the start, we're going to look at it graphically as well. So I'm going to go ahead, and I like to use my graphing software. I use Desmos.com. It's free. You can get it as an app on your phone. If you have questions on how to use it, definitely I can help you out with that. But I like to use it because it's free. Did I mention it's free? No, it works well. If you don't, you can also use a graphing calculator, but a graphing calculator is going to work a little bit differently. So when you graph using Desmos, you break it up into parts. So sticking with kind of like the parts that we have our first part, our second part, and our third part. Okay, so I'm just going to go straight down the line or typing it in, and then I'll expand it so you can see. So first one I have, y is going to be equal to x plus 3. And then I'm going to say that's for x, and I use the squiggly brackets. And you can then go and say, okay, x such that, or just you can even just say x less than equal to -4. Web Assign picks up on that pretty well. Then the second one, you have the line y equals -3. Now I think even if we crossed off the y equals that first one, yeah, they still catch it. You just want to make sure you have that. I think I like putting the y in there, but you don't have to. So then we have this -3 as our output from x equals -4 to 3, and I just use those squiggly brackets so that it knows, oh, that's my domain of x values. It's pretty intuitive. This does most. It knows what you mean. And I don't think it might even, let's see, is it like 4? Can we use 4 just like we do in the function? See how intuitive it really is. Okay, so it doesn't like that 4 in there. So you do want to put just your x values, okay? And use the squiggly brackets. Okay, so then let's zoom out now and look at what is it really saying for our graph. Well, I've got, it broken up into 3 different parts. And the biggest thing is when you graph it using these graphing utilities, they're not as obvious with those circles. So you can see the circles, but you do have to trace the graph. So you trace the graph or look at what's happening at those boundary points. Get right there at that boundary point and see if there's an open circle. Okay. So this one, you can see the open circle is actually for the blue. That's where we have that open interval. But again, I'd have to really trace it. So click right on there and then trace it. Even this one, I'm not doing a very good job of tracing it. So you have a closed circle. For some reason, this boundary point doesn't like it. Just kind of cuts me off. Sometimes what can be helpful too is just to get the other ones off. It's not letting me get right on it. For some reason, it didn't put an open circle. So that's I guess the downside with this, but you can see it doesn't have, you will have to kind of use your guidance and see that at -3, my output is not going to be -3 because I'm going to be dealing with that third case scenario. But yeah, so this is kind of a nice way to also see the graph so we can see that it's in 3 parts and they're disconnected parts. So I know then, what the graph looks like using a graphing utility. But yeah, I recommend if you're graphing it by hand, really focus in on these, what I call boundary points. So looking at, when x is less than -4, graph that first point. We know it's included on that first piece. And then maybe pick a couple values of x less than -4 and graph some more of those pieces. Right, so hopefully this helps, and then definitely reach out if you want me to kind of show you how to graph it by hand again. I can always do more examples of that as opposed to just picking from a multiple choice list. All right, thank you.